Hi, welcome to 7.7. We are going to simplify complex fractions. There are three objectives. I'm going to be breaking up these videos into each specific objective. Let's start with, I can simplify complex fractions by simplifying the numerator and the denominator when dividing. Oh, it says, and then dividing, not when, and then dividing. These are examples of complex fractions below. And what makes them complex is that you have a fraction and then another fraction on a big main fraction bar. If you take time to identify the main fraction bar, you will save yourself a lot of headache. Take time to recognize where your main fraction bar, for example, in this complex fraction, looking at this one over here, the middlemost bar is your main fraction bar. Your numerator is going to be the top half of that fraction bar, just like with a regular fraction. And the denominator is going to be the bottom half of that main fraction bar. What we're going to do in this first objective is focus on simplifying these wonderful fractions. There are three steps. Step one is to simplify the numerator and denominator first. Then perform the indicated division. We're going to use keep flip change, KFC, for step two. And step three is just making sure that our fraction is in its simplest or lowest terms. Let's just jump right in. So first identifying what my main fraction bar is, for example A, I can now focus on simplifying just the numerator. My numerator is 27. My numerator is 2x over 27y squared. And there's nothing I can simplify there. It's going to stay the same. That was a little uneventful. Let's look at the denominator. 6x squared ninths. I can simplify 6 ninths. 6 ninths is divisible by 3. That gives me 2/3. X squared will not be simplified, so it's going to stay the same. Now, what I'm going to do next is rewrite this. Right now, this is written in vertical format. I want to write it in horizontal format. The reason why is because this main fraction bar means division. And I can rewrite the complex fraction as 2x over 27y squared being divided by 2x squared over 3. And now we have a quotient or a division problem where we can use keep flip change and simplify. You would have 2x over 27y to the third times 3 over 2x squared. I'm going to simplify. We have a couple of things we can divide. We have x squared and x. This x squared is now going to become x to the first, but that x will divide. I have 3 and 27. That can become a factor of 1/9. I have this 2 and this 2, which become factors of 1. Now looking at everything that I have after I've simplified as much as possible, I multiply everything in the numerator. 1 times 1 is 1. And in the denominator, I have 9 times this y to the third and a singular x to the first. Okay. And that would be our simplified answer. Let's look at example B. You have 5x over x plus 2. That is my numerator. Remember to first identify your main fraction bar. Your main fraction bar is right here. I want that a little bit. There we go. Change this. All right. Simplifying the numerator and the denominator, not a lot happening here. I can't simplify 5x over x plus 2 any further. I also cannot simplify 10 over x minus 2. So I have a vertical format, but I'm going to rewrite it in horizontal format, remembering that this fraction bar, the main fraction bar, represents division. Okay? You're dividing the numerator by the denominator. So as I'm changing the color, you can probably already figure out you're going to have 5x divided by x plus 2. That fraction is being divided by 10 over x minus 2. I'm going to use keep, flip, change. I have 5x over x plus 2 times x minus 2 over 10. And I'm going to simplify my common factors. I'm going to divide 5/10 can be simplified as 1/2. There we go. And that's it. Do not go crazy thinking that you can cancel out this x and this x, or this 2 and this 2, because that is not what is happening in those numerators and denominators. This x is being added to 2 here. Can't simplify that. That x is being subtracted by 2 there. Also can't simplify that. In my numerator, I have 1 times x, which is x, times x minus 2. So I'm going to write that as x times x minus 2. In my denominator, I have 2 times x plus 2. Nothing to simplify any further, so this is my simplified answer. Let's go ahead and kick this up a notch. If I went too fast, you can rewind. That's the convenience of recordings. We are going to work with something that's a little bit spicier now. You shouldn't be surprised. You know how this goes. It starts kind of easy, and then it gets harder as we progress. So really be sure that you take good notes and ask me questions when I see you again. My numerator here is a whole other problem. You have x over y squared. Why don't I rewrite this in black so it doesn't look so intimidating? So you have x over y squared plus 1 over y. I'm going to simplify this numerator here first. Okay. I'm back to adding rational expressions. Same rules as adding fractions. I got to identify my least common denominator. It would help if my denominators are factored, which they already are. Y squared is y times y. Y is y. The least common denominator is y times y, or y squared. So I'm going to change. I'm going to make the second fraction an equivalent fraction where the denominator has a y squared by multiplying by y over y. I'll have x over y squared plus y over y squared. Now, since the denominators are the same, I keep them in one fraction, and I would have x plus y in the numerator. Fabulous. Now let's simplify the denominator. I have y over x squared plus 1 over x. Please make sure that you write that as a y, not a 4. The least common denominator, you guessed it, x squared. I'm going to rewrite the second fraction as an equivalent fraction by multiplying it by x over x. That gives me y over x squared plus x over x squared. The denominators are the same. I can combine it into one fraction to become y plus x. So in my numerator, I have simplified this to become this. So that means I have x plus y. I have x plus y over y squared all over my new denominator that I have simplified. Let's make it green. This is my new denominator that I have simplified. I have y plus x over x squared. It's written vertically. I'm going to write it horizontally. So that means x plus y over y squared is being divided by x, y plus x over x squared. I'm going to use keep, flip, and change. So I have x plus y over y squared times x squared over y plus x. Let's simplify our common factors. Addition is commutative. I can divide y plus x by x plus y. That's a factor of 1. X squared and y squared cannot be simplified any further. So my final answer is 1 times x squared, which is x squared over y squared times 1, which is y squared. This is my first objective. I'll see you in the next video. Thank you for watching.